I'd like to take a look at problem 12 from topic 3, a normal approximation of a binomial probability. So a probability is always x, the number of ways you can get the event over the total possible ways. Section 5.3 discusses this in a little bit more detail. Well, there's a couple of formulas, and they're found on page 332 as well, I have listed here. So what I'm talking about here now is I'm talking about the if you're discussing the x in this equation over here in yellow, then your mean is going to be n times p, and your standard deviation for that x is going to be the square root of n times p times 1 minus p, which is actually a lot of times a lot of textbooks and things call it q. If you are talking about the p part of this, of a sample, namely p hat, then you are looking for the mean of p, which is going to be exactly equal to whatever p is, and the standard deviation of p hat is going to be this. So these are actually p hats here. Okay? So number 12 actually looks at a problem like this. Says if a historical probability of an event is p equals 0.83, find the probability that p hat, some sample, is less than 0.77 or so. So if the probability of a historical event occurring is 83% for any given event, what's the probability that in a sample the probability will be less than 0.77? And the sample size is 100. So what you need to do here, okay, is you first need to calculate your mean and standard deviation. And so your mean, since we're dealing with a probability of p hat, our mean of p hat is going to equal p. So that's going to be 0.83. That's pretty easy. The probability, on the other hand, of the calculation for the standard deviation, okay, is you're going to take the standard deviation and you're going to do exactly what's there. You're going to say the square root of p, which is 0.83, times the probability of 1 minus p, which is going to be 0.17, and you're going to divide that by 100. So you're going to end up with an answer of 0.037563. I suggest that you carry it out that far because once you put it in a calculator, if you round too soon, your final answer is not going to check in WebAssign. Now, once you get those two numbers, okay, you're ready to plug the numbers into Excel. So you have a mean of 0.83, you have a standard deviation of 0.037563, or 3.75%, and you have an x of 77, or 0.77. So if I use my calculator that I created here, let's see if I can get this to come down here a little bit. No, I can't. Okay, so if I use my calculator, this is the normal distribution of my calculator. I put in a 0.77 for x. I put a mean in of 0.83. Okay, or I can round everything up to percentages and whole numbers. And I can use a standard deviation of 0.03756, which is what I calculated. Okay, and that will calculate my probability of less than this value at 0.0551. So that's the kind of thing that I want you to take a look at. Finding that and using that approximation. Now, Part C is a little bit different. There's two ways to look at Part C. You can look at it, one of the things that it says on page 299, it talks, or 321, it talks about the fact that if you want to decrease the standard deviation of a sample, then you have to increase the sample size by the power of that. So if you want to decrease the standard deviation by 2 or a half, you have to take the square of the size of the sample. So if the sample size was 200 or 100, you would have to bring, having the standard deviation would make you an n of 400, or you could actually calculate it out. So if I make my assumptions that my standard deviation was 0.0375663, and I want to cut it in half, and I put it equal to the formula that I have for the standard deviation, which was 0.83 times 0.17 divided by n. So now I'm solving for n. You solve this equation for n, and you will end up with n equals 400. So there's two ways for this particular problem to work this problem out, but this is the other way that you can find n if you want to change the value of the standard deviation by half. So you want to make a smaller standard deviation. I hope you find this helpful for solving this problem and several of the other problems. Thank you.